Hello, my name is Jake Weikert. I'm partnering with Tristan Stevens, and we'll be going over RDT for programming assignment 2. I did RDT 2.1, Tristan did RDT 3.0, and I gotta go kind of fast so he can go over his too. RDT 2.1 is a stop and wait protocol that handles corrupted data with checksums. To recover from the corruption, we will send ACKs or NACKs to the person who sent us a packet. To handle duplicate packets, if the ACK or the NACK gets corrupted, we will use sequence numbers, and in our case, we will be using 0 and 1. So as we have here, we have a probability byte corruption chance of 0. We will run this on 0 and show what it looks like under no corruption. So as we can see here, so this is the client, blue screen, or blue words are the server. Scrolling up here, we can see that no corruption is occurring. We can see that we're sending acknowledgments and updating the sequence number, and we can see that we're converting to the gibberish or the pig Latin. And then same for the rest of them. We get the final outcome. No packets are being corrupted. To tell if the packets are being corrupted, we put in a nice little print statement here that says no, we're corrupting packets. So now I'm going to change this corruption to 0.2, and we are going to run this here. It takes a little bit to run. Okay, so we can see that we have some corruption going on over here. We have 2 network corrupting packets going on, and to put these print statements in English, so it takes some time to translate. We have converting wise men make proverbs. That's being sent over, and that packet is getting corrupted, and we can see that we're getting back a NAC from that. We can see that our sender is receiving this NAC, and that the NAC is not corrupted. These 3 statements all kind of go together. We can see, or we can't see, but our packet is sending another packet, which is coming back corrupted again. We are getting another NAC, which this NAC is corrupted, which we can see here. And when the ACK or NAC is corrupted, we're just going to resend the packet. Now we're actually not getting the corrupted packets back, but we're just using print statements to show that they are occurring. So we're going to send the packet off again. This time we're actually getting the English version of it. The receiver is receiving a packet that's not corrupted, and we'll send an acknowledgement to update it. That acknowledgement is not corrupted, and the sender will update their index number as well. And we can see that we get converted wise men make proverbs to the pig Latin. Thank you.
Hi, I'm Tristan. I'm in charge of the RDT 3.0 for this project. The main goals of RDT 3.0 is that it retransmits a packet after a timeout, after a lost acknowledgement, and it will ignore duplicate packets. So to handle the timeouts and lost acknowledgements, I added these lines of code right here. What they do is they add up the time since the last data was received, and if it exceeds the timeout, it will resend the packet. To handle duplicate packets, what I did was add these lines of code. What they do is when they detect a duplicate packet from the sequence number, it will send an acknowledgement for that packet back to the sender to let the sender know that it has been received. So let's go ahead and try this out. Here I'm starting the server, and here I'm starting the client. So the program just got done running. So if you see these timed out statements, these are either a lost packet or a lost acknowledgement. The returned NACs are corrupted packets, and the returned ACT means that it was finally received correctly. And we got all of our pig Latin back the way we expected. So that's RDT 3.0.